Okay, good day everyone. So we are here to continue our lecture regarding Y-Delta or Delta to Y transformation. Okay, so my name is Engineer Reggie Marinay of Marinay's Powerhouse Team Review and Training Center. Okay, so let us have our continuation. For this circuit, we're going to apply the Y-Delta transformation in the Wheatstone bridge circuit. So this is our circuit. This is a Wheatstone bridge circuit. So I already copied this circuit on the board. So please take a look here on our board. Okay. So I use here a Kirchhoff current law to determine the three currents so that we can reduce the current flowing for each branches, for each resistors. Okay. So what I did here is the current from the 30-volt source is current I sub 1. That is our total current. Okay. Then the current at 9 ohm resistor here is our current I sub 2. And our current at 4 ohm resistor is I sub 3. Okay, we're going to use the Kirchhoff current law to determine the current flowing in the 3 ohm resistor, 6 ohm, and the 6 ohm resistor here. So take a look here. So for the current in the 3 ohm resistor here, so that will be, so the resultant current here is our I sub 1, and then just subtract current I sub 2. So therefore, the current here will be I sub 1 minus I sub 2. Since we already discussed this also in our Kirchhoff laws, so for the current here in the 6 ohm resistor, so the resultant current here is our I sub 2 minus the I sub 3 here. For the current in the 6 ohm resistor here, so that is equal to, okay, the resultant current I sub 1 because the current here is also I sub 1. Then minus I3 here. So this is our I3. Okay? Because these two, the current entering is equal to the current leaving here. Okay? So I already reduced the unknown into three unknowns only, no? Instead of making it I1, I2, I3, I4, I5, and I6, so that's too long. Okay? So we already reduced the unknown into three. Okay? Okay, let us convert here the delta connected on the upstream here. We are on the upstream here. So this is the upstream. We're going to convert this delta into Y here. Okay. So I will redraw this circuit. So we have here a delta circuit. Okay, I will magnify this delta connected resistors. So this is our 3, our 9, and our 6. Okay, again, this is the upstream delta connected resistors. So we have here these 3 resistors. Okay, I will call this as our RA. This is our RD, and this is our R sub C. What is our RA? Okay, so this is delta going to Y. Okay, our RA use the finger method, so we have here 3 times 9. 3 times 9, then divided by the 3 resistors. So we have here 3 plus 9 plus 6. So that is equal to, let us calculate this one. We have 3 times 9 divided by, so 3 plus 9 plus 6. Okay, the answer would be 1.5 ohms. 1.5 ohms. Okay, what about now for our R sub B? So this is our R sub B. That is the product of 6 and 9. 6 times 9 all over 3 plus 9 plus 6. So 6 times 9 divided by 3 plus 9 plus 6. So the answer is 3 ohms. Okay? The answer is 3 ohms. This one. We have here our R sub C. Okay? So our R sub C here, okay, that is 3 times 6. All over 3 plus 9 plus 6. So 3 times 6 divided by 3 plus 9 plus 6. Okay? The answer is simply 1 ohm. Okay? So those are the equivalent. Okay? Those are the equivalent. Okay, take a look here, guys. So we are going to replace this delta into Y. So I will redraw the circuit here. Okay. Okay, so this is our 30 volts. Okay. What is this resistor? This is our RA, that is 1.5. What is this resistor? RB, which is 3. What is this resistor? RC, which is 1. And then, of course, we have the 4 and 6 here. 4 and 6 ohm resistor. So take a look here, guys. What will happen to the 1 and the 6 ohm resistor here? So they will just be connected in series, right? And also, the 3 and the 4 ohm resistor are connected in series. Okay, so parehas na silang naka-series, no? So, we have here a circuit, 1.5. And then, the two series connected resistors, they are connected in parallel to each other, right? So, well, 1 plus 6, that is 7. 3 plus 4, that's also 7. There you are. Okay? So, we may say that this is point B. Take a look here. This is our point B. This is our point C. That is our point C. Okay? So, we'll be having here two resistors in parallel. Take a look here, guys. And that one and the other one here. Okay? 1 plus 6, so we have here 7 and another 7 ohm resistor here. Okay, then this is our 30 volt source. 30 volts. Okay? Take a look here. We have the 7 and the 7 ohm resistor. Okay. Let's get the total resistance first. So what is the total resistance? The total resistance would be our RT, which is equal to the parallel combination. Oh, by the way, take a look here. This is 7. Okay. The branch resistance 7 over the number of branches 1, 2. So identical resistor. And then, well, this is 3.5. Then we just have to add this 1.5. What is 3.5 plus 1.5? 5 ohms? Okay. So the answer is 5 ohms. See? That is the value of our total resistance. Actually, that is the question for number 6. Okay? That is a number 6 question here. The answer would be letter C. Okay. What about find the total current? The total current. Okay, so the total current, that is for number 7, I total, that is simply equal to I sub 1, right? Because that is the current, okay, from the 30 volt source here, no? So therefore, this is the total voltage and the current that will be delivered by the 30 volt source directly from here is our I sub 1 or our I total. Okay? So that is our I total. Now, so we have here our I sub 1, which is equal to what? Simply by Ohm's law. So we have here 30 volts, okay? Then divided by the total resistance, which is 5. So therefore, our I sub 1 is simply equal to 6 amperes. 6 amperes. Okay? So that is letter, there you are. Okay? Letter D. Okay, let's have now number 8. Number 8, so find the current flowing from B to D. What is the current flowing from point B to D? Take a look here from our original figure. B going to D. Okay? From B going to D, simply that is our I sub 3, right? That is our I sub 3. Current from B to D, that is the current flowing through our 4 ohm resistor. Here. Okay, since that is the current flowing to our 4 ohm resistor, take a look here guys, in our equivalent circuit. So this is the current I sub 3 actually. This is the current I sub 3. Take a look here. From B going to D, that is the current in the 4 ohm resistor. That is also the current here, right? Because they are just connected in series. This is also our I sub 3, right? Okay? So, 3 plus 4, that's the 7. So, this is the 7 ohm resistor, the equivalent. Therefore, this is our I sub 3, right? That is our I sub 3. So, again, network analysis, take a look here. The current flowing here is actually our I sub 1, right? So, that is I sub 1, which is equal to 6 amperes. And then this will divide into 2 equally. Because this is 7, this is 7. Okay? So, we may not consider the current divider theorem anymore. So, we just need an analysis here. By visual inspection, this is 7, this is 7, equal resistors. Then, the 6 ampere will be divided by 2 equally. So, again, so therefore, our I sub 3 will be equal to 6 divided by 2. So, that will be 3 amperes. Okay? That will become 3 amperes. Take a look here, guys. So, 3 amperes. Take a look here. So, we'll be having here this circuit, this circuit analysis. So that if we want to get all the branch current for each branches, we can do so. No, we can do it. Okay, so please focus here. Okay, I have a quite a bit shortcut for this solution. Take a look here. Take a look. Okay, I will erase the, I will go back to the original circuit. I will just erase this red one here, the Y connected resistor. I will make use of the Kirchhoff's voltage law, wherein it says that the summation of voltages around any loop is always equal to 0. Let me have a circuit tracing here. Since we are already given I3 to be 3 amperes, 3 amperes, I will consider this complete loop. At first, I'm thinking of Maxwell's mesh method. Okay? So, well, you can go that with our previous video We have so many discussion about Maxwell's mesh. But the easiest thing here, let's have a bit shortcut. No? When I watch the other lectures of this, he said that I don't believe with shortcut. I disagree. But me, I believe with shortcuts. Okay? Especially in the licensure exam, no, wherein they don't see the solution. No? What's important is to shade your final answer. Okay? They are not concerned with the solution. Well, in college, no, in the different universities wherein your professor requires you a solution, of course, you have to follow that, or else you will fail the subject, right? But in the licensure exam, no, we have to consider a shortcut. Okay? Of course, I believe with long method, with conventional, I believe with it. But in the licensure examination, now wherein the examiner, they don't consider solution, there you can use shortcuts. Okay? So if there are no, what do you call this? If there are no stated method, so we can go with a shortcut. Okay? But if your professor in the university said, use Thevenin's theorem, use Maxwell's mesh, he stated a particular theorem, so you have to follow that, or else you will fail the subject. Right? Okay? But me, if this is given in the licensure examination, or my professor, even in college, if your professor said, just solve, no? Any method you want. Okay, I will use this method. Because for me, this is easiest. This is easiest. Actually, I saw this in the book, but I will not use what is on the book. So, I will use what is the easiest here. This is the easiest. Take a look. This complete loop. I will consider for number 9 by Kirchhoff's voltage law at loop. What do you call this loop? A, B, D, and A. A, B, D, then closing to A. Okay? The first and the last letter must be the same because you have to close the circuit. Okay? A, B, D, then A. Okay. We have to consider this one complete loop. Okay, I will draw the equivalent circuit. Take a look here. Take a look here. So we have here, okay, the 30-volt source. And then we have here, okay, I'll make it vertical. This from A to B. So I will make it a vertical. So this is our 9 ohm resistor. And then from B to D, we have a 4 ohm resistor here. Then, for 9 ohm, we have a current flowing here. That is our I sub 2. I2. I2. And then, here, for 4 ohm, there is a current flowing I sub 3 from B to D. Okay? Take a look. This is point A. This is point B. This is point D. So we have one complete loop here. So I will just make use of the KVL. This is our circuit tracing. Again, if you are just first timer on my channel, so this is circuit. This is what we call our circuit tracing. It's just like a tracing paper, tracing. So this is our circuit tracing. Okay? So let's go now. Here, We have here 30 volts by KVL. Our circuit tracing, it leaves on the positive terminal of 30 volts. That's why it is positive 30. Okay. Our circuit tracing, if you are to trace, this is going downward. That's going downward. This is also downward and downward. The two currents are downward. One direction, one line. Here. 9 times I2. Okay. Then another minus for 4 ohm. 4, that is 4 times I3. Okay. Then that is equal to 0. So take a look here. We have here our 30 minus 9 times I2. Anyway, that is the unknown, the I2. Minus 4. Anyway, we calculated I3 as 3 amperes. That is equal to 0. So, just shift solve, no? In our calculator. This is easy now. Or, we may transpose this one. Okay? So, that will become 30 minus 4 times 3 equals, then divided by 9. The answer is 2 amperes. The answer is 2 amperes. Okay? So, this 2 amperes is letter, okay? We have I sub 2, okay, for number 9. Okay? There you are. 2 amperes is the answer. Okay? That's very easy. Okay, that's very easy. Okay? Although you can solve, you can use any other method. Okay? If you use the Maxwell's mesh, you can use the Maxwell's mesh here. Okay? Method. Okay, you can take a look at my previous video, the Maxwell's mesh analysis. We have 2 parts of Maxwell's mesh. Okay, and even the super mesh method. We have that in our previous videos. So we suggest that you go over with my previous videos. Okay. So let us have now the last problem. This is the last problem. For number 10. Okay, for number 10. Okay, let's go with number 10 problem. So, 3 resistors of 6 ohm resistances are connected in delta. So, we have 3 resistors in delta. Okay. So, this is 6, 6, and 6. Inside the delta, another 3 6 ohm resistors are connected in Y. So there is another 6 ohm. There are another 6 ohm resistor here. Okay. So we have here our another 6, 6, and another 6 here. The question is, find the resistance between any 2 corners. Any 2 corners. So, let us assume that this is point A and point B. Let us say we have an ohmmeter here that will measure our RAB. Okay. What is the value of this ohmmeter? the measured value. Take a look here, guys. We have the 3,6 ohm resistor. Let us convert this into delta. Take a look. The Y, I will convert this into delta. Then, we have that one. And we have another one here. So, I will make it as R delta. What is our R delta? Remember that our formula for R delta, that's equal to 3 times Ry. Okay, yung 3 may tatlong buntot. Okay? So, what is our R delta? So, 3 times Y. Ry. Our Ry here is 6. 3 times 6, so that is 18 ohms. Okay? That is our R delta. That is our 18 ohms. Okay? So, our Ry here is 6. So, just substitute. Our R delta, 3 times 6, which is 18. Okay. I will draw the equivalent circuit here. So, take a look here, guys. Again. Okay. We have here 6. We have another 6 and another 6 here. Then we have our R delta. Are now connected in delta also. Okay. So this is the R delta, which is 18. There is another 18 here and another 18 here. Each has 18 ohms. And remember, this is our A and B. Point A and point B. What can you say about the connection of the 6 ohm and the 18 ohm resistor here? It's obvious that they are connected in parallel, right? Because we have two terminals A and B. So that is their common nodes. Okay? And also for this 18 and the 6 ohm here, and also for this 18 and another 6 ohm here. They are just all connected in parallel. So what is 6 in parallel with 18? Okay, of course, that is the product over the sum. Okay, so that is 6 times 18 over 6 plus 18. Six times 18, then divided by 6 plus 18. Okay, so the answer would be 4.5. 4.5 ohms. That's the answer. Okay, so 4, that is only for 6 and 18 ohm resistor. Take note that we have point A and point B here. Meaning, there is a 4.5 ohm resistor here, but that is not yet finished. Okay? We have resistor here and another resistor here. What is the value of each? Again, that must be 4.5 and also 4.5 ohms. Okay? But our ohmmeter is here. RAD. That is connected here and here. Well, if you have a voltage source, let us consider we have a voltage source here, positive, negative. The current will flow here. Okay, so this is a node. One current will flow here and the other current will flow here. Right? Okay? So this current now will continue flowing here. Okay? They will split or divide into two and they will meet again someday. Okay. So they are together again here. Okay. Together again. Okay. So we have 4.5 and 4.5 are in series. So that will be 9. Right? Okay. So again, we have here, so I will put here our point A and our point B here. So I will make this as our 4.5, and then we have the series combination, which is 9 ohms. And then this is our ohm meter, our RAB from point A going to point B. They are now connected in parallel. Okay? So that will be easy. So our RAB is equal to 4.5 times 9 over 4.5 plus 9. What is now the answer for our RAB? Let us calculate. So we have here 4.5 times 9 divided by 4.5 plus 9. Okay. The answer would be 3 ohms. 3 ohms. That is our final answer. Okay? 3 ohms would be letter, letter B. Okay? Very easy. Okay. So, actually, that is a past board examination question. That is a past board problem. Okay? So, well, that will be it for today, guys. So, that completes the Y to delta, delta to Y transformation. Okay? So that will be it for today. And God bless you all. Stay safe. Thank you.